Hi everyone, welcome to my YouTube channel. I am RVS Sachni, studying in Sri Venkateshwara College of Engineering, Bangalore, in the branch ECE. Today we are going to discuss about basic electronics, the topic called op-amp parameters. The topics that are discussing in today's video are types of op-amp, properties of op-amp, and the parameters of the op-amp. The first topic is the properties of the op-amp. There are actually two types of op-amp, ideal op-amp, practical op-amp. So the ideal op-amp properties are it has infinite input impedance, zero output impedance, infinite open loop gain, infinite bandwidth, zero noise contribution, zero DC output offset. And the practical op-amp parameters are input impedance that is varies from 500 kilo to 2 megawatts and output impedance 2200 ohms. Open loop gain that is from 20k to 200k. Bandwidth limited to a few kilohertz has noise contribution and it has non-zero DC output. Open parameters. There are majorly eight open parameters. They are CMRR, which is called as common mode rejection ratio, and common mode input voltage, input offset voltage, input bias current, input impedance, input offset current, output impedance, and the slew rate. Let's discuss about each other. The first one is CMRR, common mode rejection ratio. The ability of amplifier to reject the common mode signals, that is the unwanted signals, while amplifying the differential signal, that is the desired signal. Ratio of open loop gain, that is AOL, to common mode gain, that is to ACM. So CMRR is equal to AOL by ACM. That is the ratio of open loop gain to common mode gain. CMRR is given as 20 log AOL by ACM. The higher the CMRR, the better, in which the open loop gain is high and common mode gain is low. CMRR is usually expressed in decibels and decreases with the frequency. The next one is input offset voltage. Ideally, output of an op-amp is 0 volt if the input is 0 volt. Realistically, a small DC voltage will appear at the output when no input voltage is applied. Thus, differential DC voltage is required between the inputs to force the output to 0 volts. This is called the input offset voltage, which is expressed in VOS, and the range between this is 2 millivolts or less. The next one is input bias current. So the input bias currents mean it ideally should be zero. The DC current required by the inputs of the amplifier to properly operate the first stage. It is the average of both the input currents. The figure shows that the I1 is the input current and I2 is the another input current and the Vout is the output voltage. So the input bias current means it is the average of the two input currents, that is I bias equal to I1 plus I2 by 2. The next one is input impedance. It is the total resistance between the inverting and non-inverting inputs. Differential input impedance, and it is divided into two types: differential input impedance and common mode input impedance. Differential input impedance, it is the total resistance between the inverting and non-inverting inputs. And common mode input impedance, it is the total resistance between each input and the ground. The first figure shows about the differential input impedance. It is the Zn is the total resistance between the inverting and non-inverting input. And the second figure shows the common mode input impedance. The next one is input offset current. It is the difference of the input bias current. So as it is shown in the figure, I1 and I2 are the two input currents and VB1 and V2 are the respective voltages. And Vout is the error and it is the output voltage as shown in the below. Input offset current, that is represented as IOS, that is equal to modulus of I1 minus I2. So here the error is Vout error, that equal to AV into IOS into RM, and the offset voltage is VOS, that equal to I1 RN minus I2 RN, and VOS that is equal to IOS into RM. The last topic of today's video is slew rate. It is the maximum rate of change of the output voltage in response to a step input voltage. So in this, first one is the test circuit where a resistor is connected to the Zener diode and Vin is the input voltage, R is the resistor and V out is the output voltage. Here the slew rate is delta V out by delta T where delta V out equal to plus V max minus of slew rate. It's a measure of how fast the output can follow the input signal. The graph shown in the below shows the how fast the V out is following the V in signal. Thank you for watching my video. Please like, share and subscribe.